Okay, good morning students. As you know, my name is Sudh Pandey and you are floating with me in the world of physics. This is our next topic, next chapter, next unit, which is a part of your optics. As I have already told you that the optics has major two parts. One is your ray optics, whereas the other is your wave optics. Okay, so in ray optics or the geometrical optics, we have covered so many subtopics, and in the same pattern here we will start your next chapter, next unit, which comes under the optics, and the name of that particular unit, that particular chapter is wave optics. As you know that each and everything what I already have explained to you, or in future I will explain, that totally depends upon the book written by the great Mr. Sivarma sir, and the book name is Concept of Physics. So in this chapter the first heading of is wave or particle. So that is the very interesting question, we can say, and the whole world is in search of the answer of that question, that the light is a wave or a particle. And this is the only question, we can say, that on which the quantum mechanics depends, or we can say this question is really, we can say that, a key of the exploration of the quantum mechanics. Okay, so in quantum mechanics we have an assumption that we have no particle. This is quite interesting thing, that in the whole world there is no particle, no position, no momenta. Okay, so that is the quantum mechanics that we will discuss in later classes, in the higher classes. But the starting of the quantum mechanics is based on the question that light is a wave or particle. So the answer starts from Newton. Firstly, in history there was a great scientist, and the name Newton, as you know, the greatest among the great. And he believed that light is a collection of particles. So according to Newton, light is a collection of particles. It means we can simply say that according to Newton, light is made of particles. So this is the observation made by Newton, that light is made of particles. Okay, he believed that a light source emits tiny corpuscles of light. So here the word corpuscles represent the word particle. Means you say corpuscles or you say particle, both are same. Okay, so according to Newton, the light is made of corpuscles, made of particles. And the important thing is that these particles, these corpuscles, travels in a straight line when not acted upon by external force, because Newton already explained the laws of motion. So in laws of motion he explained that if F external is 0, means if there is no external force, then the body retains its position. means whether it is in motion, then it will be in motion, whether it is at rest, then it will be at rest. Okay, so that laws of motion is certainly applicable here. So that's why he explained, he told that we assume that on the corpuscles of the light there is no any external force. Okay, because if there is an external force, so light must be changed continuously its direction, but it's not in real. Okay, so light travel in straight line, it means it not change its direction as well as its speed, we suppose. Okay, so that can be only if we consider that external force is 0. Now what? The fact that light seems to travel in straight lines and cast shadows behind the obstacles was perhaps the strongest evidence of the particle nature of light. What does it mean? It means as you take a candle, let's suppose this is your candle, and we place a cardboard in front of it like this way. Okay, another cardboard is there like this way. Okay, so all are at the same axis, we can say. Now if we make a hole in the cardboard A, suppose this is cardboard A, this is your cardboard B, so if we make a hole in cardboard A like this way, okay, then what will you see? You will see that the light moves like this way. The light moves and passes from the hole made in the cardboard A, and we get a light of the same size as is the size of the we can say that hole. Okay, so it is in the shape of a circle like this one. So this is hole, so the same size to we can say that the light of the same sized hole appears on the cardboard B. Okay, this simply represents that the light travels in a straight line. Now if we cover that hole, okay, anyhow if we cover that hole, then we will get no light at the cardboard B. It means we can simply say that the light is stopped by the cardboard A. So these are the some basic observations, some basic experiment made by the Newtons, and we can say that strongest evidence that which we can say that demonstrate that light travels in a straight line. Okay, and also as the particle can be stopped, so light also can be stopped. As the particle creates a shadow, in the same way light also creates a shadow. What does it mean? It means let's suppose this is the path of the light, okay, and if we place anything in front of it, let's suppose this is we can say a triangular shape object in the path of the ray, then we see the image of that we can say that that object. Okay, so image of that object. We already see our image on the road when we move in the daylight. Okay, so basically the shadow formation or the casting of the shadow strongly strongly refers that it is made of corpuscles or the particles. So I hope that up to here each and everything is clear to all of you. So one more important result is there, that the laws of refraction were explained by assuming that the particles of denser medium such as glass or water strongly attract the particles of light. causing a bending at the surface. What did it mean? It means Newton believed that let's suppose if this is a container and it has some fluid like water in it, and when the light ray comes, so light ray comes like this way, and this is your normal, and it bends towards the normal like this way. So the bending is due to the bending, whatever is there is due to the attraction, between glass or water. Okay, so the bending of light. So light is made of corpuscles. It means a corpuscle is coming and we have a glass or water or whatever. Okay, so we have two different molecules are there, and different molecules have the force, that is the adhesive force, and due to that force of attraction it bends, and as a result we simply say that the speed of light increases. Because there is a strongly attraction. So if let's suppose if you have an object, suppose this is your object, okay, and you attract this, it means you apply a force on it, and because this is a force of attraction, so F equal m into a, and a is nothing but change in velocity. Okay, so rate of change of velocity, it means velocity changes. And as Newton believed that it is a force of attraction, and that's why the velocity must be increasing. Okay, so these are the some basic points on which the Newton strongly believed that light is made of the particles. So what are those points? Once again, number 1, light travel in straight line. Number 2, light casts shadow. Number 3, it bends towards the normal when it changes its medium. Okay, and the region of that bending is the strongest force, we can simply say that. Okay, so if there is a strong force, then that due to that strong force a velocity will be there, that velocity will be increasing. Okay, so we can simply say that in any medium the velocity increases. So I hope that up to here each and everything is clear. Now what? A scientist was there, that Dutch physicist Christian Huygens, who was a contemporary of Newton, suggested that the light may be a wave phenomena. Means we have one side Newton, and in the same time period there was another scientist, Dutch physicist Christian Huygens. Both are in the same period. Okay, and the Huygens explained that light is a wave, it is not the particle. And although it is we can say that it is a wave and it travels in a straight line, the reason may be, okay, so according to Huygens, the reason may be the wavelength of light much smaller than the dimensions of the opening and obstacles. So it means if the light, we can simply say that the light is moving like this way and it passes from a tiny hole. Okay, so according to Huygens, whatever the dimension of that tiny hole is much greater. Okay, is much greater than the wavelength of the incident light. And that's why we can simply say that there is a path. So one hole, after that another hole, It means we can say that these are so many holes are there, and the structure is like a pipe there. Okay, and in that pipe light wave moves like this way. Okay, so because it is although a wave, but it travels inside a pipe, that's why it seems that light travels in a straight line. That is the we can say that the suggestion of the Huygens. So a wave also can travel in a straight line if it travels through a pipe. And what are those pipes? Pipes are the obstacles, which are assumed to be the much greater in dimension with compared to the wavelength of the light. Okay, and what is the result of this one? What is the result? So result was that whatever Huygens proposed, because as I have already told you that the Newton and the Huygens are in the same period. Okay, so Newton was at that time a great scientist, the world famous physicist, we can say, and Huygens was not at that level as the level of the Newtons, and that's why the Huygens proposals means what Huygens told that light is a wave, that theory remained a dump, and the time period is too long, about a century, and so nearly 100 years. No one believed that Huygens has some, we can say, the importance. Everyone believed in Newton, and Newton explained that light is made of corpuscles, light is made of particles, so everyone believed that light made of particles. But the things changes, as we all know. The scientific community believed in Newton's writing, so the world also believed, and as I have told you that the scene changes every time. So after a long time, means in we can say that during 70s last or 18s earlier, in 1801 there was a scientist named Thomas Young, and he performed an experiment, the very very famous experiment that is known as Young double slit experiment. Young's double slit experiment. On the behalf of the experiment, that is in 1801, Young also supports the theory of the Huygens, and he with the help of his experiment he explained that light is a wave, not the particle. And how he says like this way, because the experiment established that light coming from two coherent sources interferes and produces maxima and minima. It means if we take two holes like this way and we place a screen, we place a source, then the light ray, this one, like this one, okay, so light wave passes through these slits S1 and S2, and at a point they superpose, and let be the point P is the point at which the two waves coming from the slits S1 and S2 are superposing. Then we get a unique thing there, that we have two conditions arises, that it may be bright or it may be dark. So bright means maxima and dark means minima. Okay, so on the behalf of that, because particle cannot superpose, only light can superpose. That's why on the behalf of his experiment, Young told that light is not a particle but it is a wave. That's why it shows the path difference as I have explained here. So this is your path difference. Okay, so Young double-slit experiment we will explain in later on. Okay, but here it is necessary to understand that what basically Young done in his experiment. Okay, now there are a series of experiments on diffraction of light that is performed by the French physicist Augustin Jean Fresnel, and also calculate the velocity of light in water by Foucault in 1850. And the thing was changed because according to Newton explained that the light of speed in water is greater than the light of speed in air. But when in 1850 Foucault calculated, that was only a coincidence that he calculated the velocity of light, but whatever. Okay, he calculated the speed of light in water and found that Newton was wrong. The speed of light in water is less than the velocity of light in air. So this is according to Foucault. And by experiment, it means now there is a time that world believe that Newton may be wrong and the Huygens may be correct. And there are so many scientists are in between that time who perform a number of experiments of the light to prove that light is a wave. And one famous name is there, and that is Maxwell. In 1860, he also predicted the speed of light and also put the corpuscle theory of light to an end. It means after the theory of the Maxwell wave theory, okay, so electromagnetic theory. So after the final development, whatever is started from the Huygens and come to the Maxwell electromagnetic theory, finally there is an end of the corpuscles theory given by Newton. So what now is the answer? That light is a wave, not the particle? No. This is the word of physics. This is the inventions. This is the observations. This is the we can say the chance to explore each and everything. That's why the drama was not yet over. The climax came when the wave theory of light failed to explain Hallweg and Lenard observations in 1900. So Hallweg and Lenard explained that if we have a metal sheet like this way, this is a metal sheet, and when the light waves comes out, then the electrons, photoelectrons, emits out. But in case of wave, as I have told you that if this is your first wave, this is your second wave, then wave can superpose only. It cannot extract the electron from any object or any body or any surface. That is the nature of the particle, because as we consider that if we have a carom board, okay, this is your, we can say that some coins over there, and there is a striker, and when a striker hit on the coins, then it is possible that any one coin come out. But the wave cannot have such intensity that a coin can come out. So how the electron can come out if it is a wave? Because wave can superpose only, but it cannot have such intensity so that it can extract the electron from the surface. And that is the observations of Holweg and Leonard, and which is forwarded by the Hertz. And that observations is known as the photoelectric effect. So when photoelectric effect came in light, then the question once again comes in front of us, that is the light a particle or a wave? Albert Einstein, you know very well, in 1905 also reopened the question, and also believed that on the behalf of photoelectric effect, that light is a particle. So there are several observations, several experiments who have already explained on the behalf of the wave theory, and strongly believe that light is a wave. And before that experiment and after those experiments, there are several experiments which explained that light is a particle. So finally, and up to now, we believe that the light has a dual nature, means light is a particle as well as a wave. Okay, so this is the history of the light. This is the nature of the light. No one can 100% sure that light is a particle. No one can 100% sure that light is a wave. So we accept finally that light has a dual nature. So I hope the journey of light, you enjoyed it very well. And we will discuss, we will continue each and every topic in front of you. So just to enjoy the journey with me, and thanks for watching me, thanks for listening me. Best of luck to all of you.